So this is our review for summative number 3 in the fall of 2019. And the first section that you guys see, this is a repeated section. You already have scores on solving systems by graphing, but you're all going to get a new score tomorrow. So you're going to be responsible for solving by graphing, solving by substitution, and elimination. And it's very specific as to which one you have to approach it with. So number 1, Anna's going to help me graph the line. You're going to tell me where to start graphing my line for, let's do this one. Whoa, yuck. All right, x plus 2. Where do I start? Very good. I crossed it out halfway, but I think my slope is 1 over 1, isn't it? Am I in the right? Is this a 1 in front? So up 1, right 1? Okay. Up 1, right 1. And then everyone knows I can't really graph a line, so I'm just going to pretend like I'm graphing a line by continuing on. Are we doing neighbors? Are we going neighbors, Mrs. Meyer?
No.
No. Shake it up. Who's going to help me graph my green line? Anybody?
Just make sure everybody's got a package.
Gotcha. You want to graph the green line? All right, go ahead. Start at -2. Nice. Nice. And you found the intersection point. Ooh, see, this is why I don't graph lines. That reason right there. Now, the ordered pair in which they intersected, we need to write that as an ordered pair. So, Chris, you want to tell me what ordered pair that is?
1 and then y 3.
Very nice. And that's exactly what I would like to see, except you guys would actually draw lines. Nice job, team. So that was a really nice question. Some traditional slope-intercept lines, but we know they're not always traditional slope-intercept lines. So let's take a peek at number 3. James, help me graph this first one. We'll call it the blue line. Where do I start? Good. Yeah, normally you'd go up and right, but we're going to fall off the graph. So you're suggesting I move down 5 and then where? If I go right, I'll be negative because that'll be a negative slope. So if we go down and left, that would be negative over negative, which is secretly positive. Very good. All right, there's no way I'm going to be able to graph this line today, guys. Let's pretend there's a line there. All right, the next line is a special line, y equals -1. Not in slope-intercept form because it's one of our special lines. Who's got this one for me?
Wes.
All right, Wes, what does it look like? It is a horizontal line through y equals -1. Very nice. So I can see, if I actually had a line, that'd be nice, but I can see that they do intersect. Wes, what is the intersection point? Very nice. All right, but if you guys remember, one of the problems that some of y'all had, and I don't have a question like this on your review, so I apologize. Sometimes our line looked like this. Is this in slope-intercept form? So this is the challenge some of us faced last time on the test, was we had to do a little manipulation to get it in slope-intercept form. So I need a volunteer to help me rearrange this in slope-intercept form. Go ahead, Rob.
Subtract 2 from 2x from
2x from both sides. Very good.
and then divide both sides by 3.
Very good. And do you mind if I kind of rearrange the order? Instead of 6 minus 2x, if I write down...
2x minus.
Very nice. That way it's literally in slope-intercept form. So some of these lines will take a little bit of work on your part. You might have to subtract or add and also divide some terms. The one on your test last week looks like this. It was like 1/2 x plus y equals 4. And then some people told me when they graphed their line that their slope was a positive 1/2. What do you think about that? Because it's not in my special y equals mx plus b form. So this one's a lot easier to manipulate than Rob's question. You just have to subtract the 1/2 x over. So the slope is really a negative 1/2. So watch out for that on your test tomorrow. I think that was a whoopsies on my part. Your test does have some manipulation that you have to do before you can graph. Okay? So solving by graphing. I have high hopes for it this time, guys. Okay, let's talk about substitution. Now, when we solved by substitution on the last test, Mrs. Meyer and I were very nice to you guys, and you had like x equals formula like already sitting there on your paper. So all you had to do was say, oh, x equals, and then you plugged it into the other equation. Well, you're not so lucky this time, guys. We're going to step it up a bit. This system is not set up to substitute quite yet. Who's going to help me set one up for I? All right, Austin, who looks like the best variable to isolate in this problem? Yes, so he's looking for singular variables that have ones as coefficient. This is the easiest thing to isolate. So what are you going to do to isolate the y? Very good. Subtract the 8x over. So what does your other side of the equation look like? Love that. He literally did what he told me he was going to do. He subtracted 8x to the other side. I think that's great. So what that means is now, whoever's getting the next part of the question, whatever y, whenever I see y in the next line, I'm going to replace it with 15 minus 8x. And who am I talking to? Who? Jacob. So this line right here, I'm going to start writing negative x minus 4, but we're not going to call y y anymore. What is y? Very nice. And then the rest of the equation says equals 2. So a little simplification, Jacob. Let's distribute the negative 4. And I want to hear everyone reaching for their calculator right now because I cannot tell you how many times I had to mark people down for what are basic computation mistakes that could have been avoided by using some calculator checking on your test. So I'll start off the equation. I know it was negative 8x. What's my next term going to be, Jacob? Good. And then positive 32x. Very nice. Equals 2. All right. New person to solve? All right, Devin. I want to collect my like terms on the left side. So negative 1x plus 32x, better known as 31x. Thank you. And there's still a minus 60. So now we're ready to move the constants to the other side. And remember, ooh, that's a 60. Mrs. Meyer and I promised you guys that we would always give you systems that worked out nicely. So if you do all your work and you find out that you have a fraction or a decimal answer, something's wrong. You need to go back to the drawing board. Devin, did you solve this? You divide by 31 on both sides. Did you get a value for x? Very good. So if we're writing this in ordered pair notation, that's going to go in the x position. I had a couple of people last week invert their ordered pairs. You'd put the x where the y goes and vice versa. So watch out on the ordered pair. Yeah, good news, Devin. This recipe up here that Austin rearranged for us, this is going to help you find y. So we're just going to plug into that. And you just found that x was 2. So you can, guys, you can just straight type that into the calculator, but 15 minus 16, better known as negative 1 thunder stealers. There we go. Sorry, that works a little messy. I didn't mean to go all over the place there. So that's what you're going to see on your substitution part of the test tomorrow. It's going to be a little trickier because you got to do some rearranging. So just like earlier when I asked him who's the easiest variable to isolate, you're going to look for the variable that has the smallest or possibly the 1 as a coefficient. All right. Elimination, everybody's favorite. Oh boy, who's going to help me eliminate? We got some decisions to make.
Dylan.
All right, Dylan. You want to eliminate x's or y's? All right, let's check out the y's. You have a positive 3y and a positive 5y. Those are surely not going to eliminate. So do you have an approach that you'd like to use here? Okay, so we need them to be the same number, but they have to be opposite numbers. So at some point, I need to change one of their signs to negative. One technique, if you guys are kind of at a standstill and you're like, man, I don't know what to do. You can just multiply each equation by the other number from the other equation. So like for instance right here, if you multiply this top equation by a 5 and the bottom equation by a 3, both of your y's are going to come out to 15, Dylan. But what else do we have to fix? Because 15 and 15 won't cancel. If one of them was negative, it would. All right, your choice. Do you want to make the top or the bottom one negative? There's no wrong answer. Just pick top. Okay. So this is a step that I think some of you skipped. And yes. On number 5? Okay, we'll come back and look at that at another time, okay? So number 7, we're going to distribute through, and we need to write your new system. Some of you never did this step, and you tried to do some amazing mental math, which was very dangerous, and it backfired. So this top equation becomes a positive 20x minus 15y equals negative 5. And then this bottom equation is now a 27x plus 15y. Did I do something silly? Well, we'll find out. All right, what's 3 times negative 14? I need help there. 42, negative 42. Confirmation on that? Okay, cool. Oh, no, we're good. I got nervous for a minute. Who's helping me finish this problem? David. Are your 15s going to cancel from Dylan's work?
Yeah.
All right, cool. Negative 15, positive 15y gone. Add up your x's. What do you get?
47.
Cool. 47x equals, this adds up to negative 47. All right, I'm feeling good because this is going to come out nice. When you divide by 47 on both sides, what value did we just find for x? Negative 1. Okay. So your ordered pair, David just found the x was negative 1, but I also need to find the y, David. How do I do that? You got to head all the way back to the beginning of the problem. Pick your favorite equation from the beginning. We could. You could do that. That's actually a neat approach. If you love elimination, you can go back and try to knock out the x's instead. The other thing you can do is, since you know what x is, go pick your favorite equation from the very beginning. Do you like the top equation or the bottom equation better? Top one? Okay. So if we took the top equation and I rewrote it, but I replaced x equals negative 1 where it belongs, you get negative 4 times negative 1 plus 3y equals 1. And this is an equation that we're going to be able to solve. So negative 4 times negative 1 is a 4. We're going to subtract 4 from both sides. And we have, let's see, 3y equals negative 3. And coincidentally, y came out to negative 1 again. So elimination, it always cracks me up as a teacher why kids like elimination the best. Because I actually find it to be the most tedious one for work. I think it has the most work in it. But you know what? To each their own. All right. That one was set up for elimination. And remember, guys, on the test, you don't get a choice. If it says you must solve by elimination, you must solve by elimination. Questions so far? We're going to move on. So we're all getting a new score on systems. Even if you killed it last time, you better kill it again. This is also a section that you guys already had a score for. We had the very end of the test last week was 1.5 compound inequalities. Oh, speaking of which, remember how I gave you bonus questions last week on the stuff that we tested already? I did it again. So you're going to have a bonus question on systems. And you're going to have a bonus question option on this one as well. Okay? Yes, they're tricky. But remember, guys, there's no risk. Try it. If it doesn't work, you don't lose any points. At least you can give it a shot.
Darn it.
So, number 9. The way this one's set up, does anyone remember what we called these problems where there's like an algebra in the middle of two things? Yeah, we called them sandwich questions. And while that was a little cutesy of us, the reason we call them sandwich questions is because the x is sandwiched, or m in this case, sandwiched between the inequalities. And it also helps us remember that we are looking at an and question. So even though it doesn't say and, we're supposed to know that it's going to be an and. So we love it when you guys write little lines down your equal signs, or in this case, inequality signs. Who's going to help me solve, Mrs. Meyer? All right, Adrian, I want you to solve for m. What would be your first step? Yeah, and by both, do you mean like all of them? Yeah, so Adrian's going to solve all the problems at once.
Oh, never mind.
So we have negative 10 is less than or equal to 2m. Now be careful, there's only a less than symbol on this one. Less than 12. One more step, Adrian. Very good. Everywhere, right? Cool. So we end up with negative 5 is less than or equal to m, which is less than 6. Now we know that sandwiches are ands, and you guys have been working a lot with ands lately. So who's going to help me graph and give the inequality, or the interval for this one? Dallas. Number line. Not a trick question. Which number comes first? Negative 5 or 6? Very good. And then remember, this is a little backwards. I know some of you panicked on the last test because you thought like you were graphing the wrong way. Ands in this section will always go together like this. So this really says Dallas needs to graph everything greater than negative 5 and less than 6. So where am I shading? Okay. Very good. So in between the two, the intersection between the two. Very good. One more question for you, Dallas, on the number line, though. What sort of symbols? Very good. Very nice. Do you see what Dallas did there? The -5 needed a bracket because of the inequality with the equal to symbol. 6 did not have that, so we used a parenthesis. Now the interval should be nice and easy. You just kind of pick up what you just graphed for me and just draw it as an interval. So it starts at, keep going, Dallas. Yep. -5 to 6. Awesome. So I'm going to ask you for all 3 things, just like I did on the last test. You got the algebra, and then I'm going to say inequality, number line, interval solution. So if y'all skip to number 11 with me, that is not a sandwich question. In fact, it is an or, because it says the word or. Dead giveaway. I'm not going to put a trick question on the regular part of the test, guys. I know some of you were thinking, oh man, she's going to do those weird all solution, no solution things. Not on your regular test this time. Okay? So don't panic. We're not going to do those weird star questions. But I do need some people to help me solve. Who we got? Abby. Let's solve this first inequality. Has nothing to do with the other inequality. What are you going to do first to solve for A? Very nice. So what do we have still over here on the left side? Good. Greater than 20. Good. I love how Abby didn't drop the negative in front of that 2A, because a lot of kids do. So good job. All right, next up. Divide by -2. So we have to flip the sign, and it is a -10. And everyone caught why Abby flipped the sign there? She divided by a negative integer, so that rule applies anytime that happens in her algebra. I'm going to drop the or word down because that is part of my solution. Who's going to help me solve the other one?
Caleb.
All right. Okay, let's get it. Very good. Oh, not add the one. You were like so convincing. I was like, yes. She meant subtract. Subtract the 1 from both sides. I really wish I spaced that out more. All right, so right now you have, let's see, -10a is less than or equal to 20. What's your next step? Mm-hmm. So A is, what'd you say? I'm sorry. Okay, I like the -2, but you just divided by a negative, and Abby did that same thing, so we got to flip the sign around. Very good. So both of the ladies' inequalities had that issue where they divided by negatives and had to flip. Thank you, thank you. It's time to graph. Now in your brain, y'all should be thinking about what an OR should look like. Whoever's going to help me graph, you got to help me put the numbers in the right order. All right, Justin, which number shows up first on my number line? The -10 or the... Yeah. And then I want to graph everything. This is a less than symbol, so less than -10. So I should graph less than left.
Oh, so left.
You guys are so paranoid about my dyslexia. You're really trying to help me out. I just view it as an arrow. Like I go like, whoop. What kind of symbol should I put on the -10? Mm-hmm. All right. And then for greater than or equal to -2, I should shade to the right. And what sort of symbol goes on the -2? So this time, because there's an equal to on it, we're going to use a bracket. Right? All right, interval. You want the interval or you want to pass it? I'm going to pass it. To whom?
Sean.
Sean, interval, please, starting on the left. Yes. Nice. Yes, it's called a union symbol, but you're right, it's not quite a U. What else you got? Nice. Yes, a normal parenthesis. Yep, I gotcha. Infinity's never laying there, so you got to have a parenthesis there. Nice job. Woo! Gonna have some ands and ors, followed by a bonus question. Woohoo! Can you all do me a favor? Just try the bonus question, even if it's a hot mess at the end. I want to see what you're capable of. Okay. Finally, we get to new stuff. So no one has scores for these yet. So I'm going to need people to reach back into the recent memory here. We've been solving absolute value inequalities. Notice the instructions, guys. Be sure to provide both solutions. Capitalize. What does that mean? You're going to have more than one solution. In fact, you'll have 2 solutions because you're going to set up how many problems? 2. All right, who's helping me set up my 2 problems? All right, Richard. First question. that you set up, you just take the absolute value bars off. Yeah. The second one is the one I'm trying to remember. How do I set up the second one? Nice. Very nice. Notice he didn't change the algebra inside the bars. That stayed. But his solution is now negative 11. All right, Richard, let's solve. We're going to subtract 5. And if you guys are on a roll, you can technically subtract 5 everywhere. Because it's the same math. You're just getting a different solution. All right, Richard, what do we have here? And I want to hear clickety-click-click-click on your calculators, y'all, because this subtracting negatives business, this is where I keep seeing mistakes that are costing you a lot of points on your test. 11 minus 5, better known as a 6. And then over here, negative 11 minus 5, which is going to give us a negative 16. Good. Now Richard's going to continue by dividing by 8, and then some of you are going to panic because you think you never get fractions in math, but we do today. Okay, these, I'm not promising you anything. You can have fractions. So on Richard's calculator, he's going to type 6 divided by 8, math enter, enter. Easiest way to get a reduced fraction. Man, I need to write smaller. You get 3/4. Yeah. And then on the other one, negative 16 divided by 8, better known as negative 2. Very nice. So that's Richard providing us both solutions. Awesome. And then we get a little crazy when I look at 15. This is the question I'm very worried about just because I remember what some of you did on your homework. Who's helping me now that I've really scared them all? All right, Dawson, I need to solve 15. I know we're going to set up 2 problems. Is this the moment I set up 2 problems, though? Nice. So Dawson is isolating the absolute value bars. Perfect. His new problem says absolute value of x minus 4 equals 4, and now we can set up our 2 problems. All right, Dawson, go ahead and set them up for me. Nice. Very good. So again, notice he set up the algebra, never changed. The only thing he changed is on the second problem, he negated the solution. All right, take it home, kiddo. Add 4. Very nice job. X equals 8 and x equals 0. Providing us both solutions just like the instructions said. Nice job. Okay, you get a whole score for that section, guys. It's 2 problems. Okay? I'm hoping to see some nice 5s there. Some of us could use a nice 5 in our grade book, you know? And then there's this. Okay, before I start this section, I need someone to give me a little rundown of what are we looking at. You want to tell me about ands and ors? So if it's this one, that's an and. So if it's the other one, it's an or. Now all the rules about ands and ors apply here. Very good. So when I look at number 17, Kobe, are we looking at an and or an or? It is an or. Can you set up your 2 problems for me? Greater than or equal to. Yep. I'll put the or down. Very nice. Look at the 2 things that Kobe changed for you. He flipped his sign around on the second one, and he negated the solution. So on inequalities, you got to change 2 things because you got to move the sign. You got to reverse the sign as well. All right, so very similar to the other OR questions we got to solve. And the good news is all the math looks the same, just the solutions are different. Want to keep solving? Very good. I'll just go over here and do the same thing. Nice. There you go. Thank you. Very nice. So when I ask you guys for the inequality solution, that's what I'm looking for. What about the kid who forgets to write the word or down? Is that going to earn a 5? The word or is part of the solution. You have to put the or down. All right. Number line time. Who's helping me graph an interval? All right, Haley, which number shows up first on my number line out of my 2 solution endpoints? 4, very good. And in your head, you should be thinking what an or looks like. Should be pretty typical on our test tomorrow. For the 4, I want to go everything less than 4, so which way should I shade? The left, good. And then what sort of a symbol goes on the 4? A bracket, very good. And then on 16, I should shade greater than 16, so that should be right. And that's exactly what an OR should look like, so I'm feeling like we're on the right track. Interval time, Haley. Where does it start coloring blue? Very nice. To 4, close the bracket. Okay. Yep, and then a little symbol in the middle to join them up. A union symbol, very good. Excellent. Okay. So that was an OR. Ooh, let's look at 19. It's a good one. Am I even ready to determine whether it's an AND or an OR yet? Because it's not isolated. This is kind of like Dawson's problem earlier where we had to do some isolation first. You should always look to isolate before you even consider ANDs and ORs. Who's helping me, Meyer?
Michael.
All right, Michael. Isolate. What are we going to do first? Very good. So moving the 7 over by adding it. New problem is absolute value of m minus 6 is less than 4. Yeah, less than 4. So now you can tell me, AND or OR? It is an AND. And my little dyslexic brain goes less than, and, land, and. Okay. We cannot tell you that. That's one of your concepts you're supposed to know for tomorrow, okay? Give me your 2 inequalities that I should set up, though.
M minus 6 is less than 4, and M minus 6 is greater than negative 4.
Awesome. Notice the 2 things he changed for me. On the second setup, he reversed his sign, and he gave me a negative solution instead. Awesome. All right, we're almost there. And it's an AND. That makes me very happy because they're my favorite. All right. Can you rattle off what your inequality solution looks like, Michael?
M is less than 10, and M is greater than 2.
Very good. Notice the word AND in the middle of his inequality has to be there in order to get a perfect score here, guys. You need both. Or all 3 parts here. Okay, graphing time. Who's helping me graph and do the interval? All right, Rob, which number shows up first?
2.
Yeah. Yeah. All right. How do I graph this?
Both of them have parentheses and you shade them to
Very nice. Ands are lovely, aren't they? Greater than 2 and less than 10 looks like that. In between them, like that sandwich question, essentially. And then your interval is even nicer because you just pick it up off the number line. Where does it start and end?
2.
Ends at?
10.
Awesome. I love ands. They're the best. Thanks, Rob. Oh, I bet you have to turn the page. Hoo, hoo, hoo. That is a lot of exponent problems, Mrs. Meyer. Oh, boy. Okay. Have we called on enough people today?
I have gotten almost all over.
Okay. Should we give y'all a break? Because this is going to be a team effort on the next few. You're going to start shouting things at me. Make sure they're appropriate and correct. -5. There's no -5 in the problem. Okay. I'm going to stick to the left side of the paper. There's basically 2 of every kind of question. That's why I'm doing every other one. This is the new stuff, the exponents. And if you remember what we were working on the last few days, I don't really like the text that the font is coming up in, or the font that the text is coming up in. So one thing you might want to try is to just rewrite it with little multiplication dots outside of everything. I don't know if that helps you or not, but it helps me. So now I think about my 3 rules for exponents. What are those 3 rules, guys? What can you not have?
No negative exponents.
No negative exponents in your final answer. All right, cool. What else can you not have?
No parentheses.
No parentheses. And the third thing, you got to make sure everything's all of them are combined. All combined. So what they mean by that is any like term, any like base is combined together. So good news, we don't have parentheses, so that's not an issue. Definitely have lots of negatives. It is my suggestion to you guys that you actually leave the no negative rule. I'd leave it to the end of the problem. It's usually better for kids if they just wait for the negative movement until the end, because then you don't make a silly mistake. So let's talk about combining some things. Starting with, 3 is who can give me a vocab word for what 3 is? It's a coefficient. There's no other coefficient, so your coefficient for your answer is going to stay as 3. But let's talk about how we can combine x to the negative first times x to the negative second. What do you do with your exponents here? Combine how? Add them together. Very good. So this becomes x to the -3. Now we're going to do something similar, same property here with the y's. You got to add those babies together. And you get y to the -1st. And then I look at that answer and I go, yeah, that's not going to cut it because one of my rules says no negatives. So because x and y have negative exponents, that requires them to move down to the denominator. What about the 3? Good, 3 stays. So 3 is still up in the numerator, but now you have x to the +3rd power times y to the, you can put a 1st power, guys. There's nothing wrong with doing that. There's also nothing wrong with leaving it alone. And you also don't need that little dot in the middle. Basically, I'll take any answer that's equivalent and simplified. Can we say yay for number 23? Yay! Because it's 1. Because the rule says anything raised to the 0 power is equal to 1. Anything raised to the 0 power is 1, guys. Whew, that was good times. So then you're all excited and you're like, whoa, look at 25. Is the answer 1 on 25? No, the only thing that is a 1 is this x to the 0 power part right here. So this guy's a 1. So the 1 combined with a whole bunch of other stuff doesn't do anything to the problem, so I'm just going to like ignore that term. Let's call it 2 times x over 3 times y to the 3rd. This is a really weird question, guys. Look at your coefficients. I have 2 over 3. Does that reduce at all? No, it does not. What about x over y's? Is that combinable? Do we have any negative exponents? So what's going on? We're done. That was a really lame question. That was easy. I probably won't be that nice on the test, though. You can dream, though. I'm going to get a little crazy. I'm going to jump to number 26. I know I said I wasn't doing evens, but I lied. I really like 26. I'm going to rewrite them with the multiplication dots. Oops, except I should write it correctly. Now notice in the denominator you have a coefficient of 3. Keep that separate. Because 3 is in the denominator, can you guys tell me what your true coefficient is to this problem? Ah, very good. There's a 1 over 3 right here. With 3 being in the denominator, there's secretly a 1 in the numerator. That is a coefficient. Keep it separate. Don't do exponent stuff to it. It is a coefficient. Leave it, leave it. Talk to me about how we reduce this, though. X to the 4th over x to the 3rd. You're supposed to do something with their exponents when you divide the bases. You're supposed to subtract. That's the rule. So, I'm going to write the 1/3 just because I want something in my numerator and denominator. Talk to me about x to the 4th over x to the 3rd. When I subtract them, I get x to the 1st in the numerator. Careful here, guys. I want to hear a clickety-click on my calculator when this is a test question. -3 minus 2. That is y to the -5th power. Now notice I just placed that in the numerator. When you use this subtraction rule, everything starts in the numerator. Is this a good final answer, though? Nah, you can't have negative exponents. So this is going to move down to the denominator. Everything else can stay. Hey, in hindsight, do I really need that red 1 I keep drawing? Not really. So if you just wrote x over 3y to the 5th power, that's a great answer. If you kept it as 1 times x, that is a great answer too. Oh goodness, I've got 27. Need a little help because 27 has every single thing I can't have, it has it. So where should I start? I gotta make this better, guys. Can we talk about the parenthesis issue? What are you going to tell me to do with that -4 power? I heard someone whisper distribute. Very quiet. Alright, so the x to the -1st power and the y to the -3rd power, nothing happens yet. I'm just going to rewrite them. But then this blue part, this becomes x to the... Now what do you do with the existing exponents when they're on top of each other like this? They multiply. Very good. They multiply. So this becomes x to the -12th times y to the +12th. All right. So again, technically there's more than one way to move forward. My suggestion to you is to not use the negative exponent thing until the end of the problem. Let's try to combine them first. So let's talk about x's. X to the negative first combined or multiplied to x to the negative 12th. You're supposed to do something with your exponents. What are you supposed to do? Add them up. So that becomes x to the negative 13th, which I know some of you are like, draw it on the bottom. I know, I'll get there. All right, and then the y's, you got y to the negative 3 multiplied by y to the 12th. And same rule applies here, guys. You're going to add them. So that gives you y to the 9th. Now, clearly that's not a good final answer, because anything that has a negative exponent has to move. So the y to the 9th can stay. And then the x to the 13th gets moved to the denominator. And now it's positive. There's your final answer. Oh boy. That is a lot of good times. Hey, did you notice the answer key to this packet is on the back of your packet? So that's why I didn't bother posting a key. So, ooh, yeesh, 29. Yeah. 29 real quick. You're going to need to smush this numerator together for me because this is too much to look at. So look at your coefficients, guys. Up top you have a 3, and then later on you have a times a 2. That smushes together, multiplies together, and becomes a 6. And maybe let's combine these x's real quick because there's just a lot going on. So you're going to add your exponents, and you're going to get x to the 2nd. And same thing with the y's. You're going to add your y's up. You got negative 1 there. And that was just the numerator. There's also some stuff going on in the denominator. Now in my denominator, I had a coefficient of 4, and then I had a y of 3. Okay, I got bad news, kids. You have a lot of simplifying to do still. 6 over 4, you have a reduction for that. 6 over 4, you can just type 6 divided by 4. Math, enter, enter. And what does that reduce to? 3 over 2. Now the x to the 2nd power, there's nothing to combine it with, and it's positive, so leave it where it's at. But let's talk about the y's. When you divide your y's like this, you're supposed to subtract your exponents. So that becomes, careful on the calculator if you're on a test, negative 1 minus 3 is a negative 4. Notice where I placed it right now. It starts in the numerator. Is that where it's going to stay, though? Nah, we're going to move it on down to the denominator. So final answer, 4 years later. 3x squared up top, and 2y to the 4th in the denominator. Real quick, I know we're almost done here, guys. Can we talk about the distribution of the 2nd power right here? I'm very concerned that kids are going to tell me this. Now, don't write this down. They're going to tell me it's 2x to the negative 2, y to the negative 2 up top. Is that correct?
No.
Why not? What'd they forget?
2 also gets the exponent.
Aha, the coefficient, if this is how it's written, also gets the exponent. So keep that in mind as you guys are trying to simplify. Down here in the denominator, I might just kind of rewrite things. This is like 2 to the 1st, and what else we got? X to the 4th, and then y to the 3rd when you combine those. All right, so your test is tomorrow. If for some reason you guys are not here to test tomorrow, we'll be pulling you out of class on Monday to take the test, so make sure you are ready. Thanks, 4th hour, for recording. Everyone else will appreciate that.